Hello and welcome to the CIBSE West Midlands region CPD on Building Regulations Part F and L in association with Vent Axia. This seminar will overview Parts F and L1A of the building regulations and discuss how they work together. The seminar will also demonstrate the various ventilation solutions within approved document F with animations showing how they work. It will explain most energy efficient solutions and complement Part L and demonstrate best practice in the design and installation of MVHR systems, mechanical ventilation and heat recovery. Case studies are also used to show how MVHR systems can help in various situations such as noise ingress problems and energy efficient dwellings. Our presenter today, amongst others, is Dave Sherratt, who is the Residential Specification Area Sales Manager for Vent Axia, with over 19 years of experience. He helps M&E consultants and national house builders achieve approved document Part F and L and Purge Ventilation, and more lately Part O and these new requirements and their compliance. He has a wide range of experience from typical houses with simple fans to developments of 1,500 apartments with acoustic and specific filtration requirements. Famous projects he's worked on include the Warden, the Good Luck Hope, Elephant and Castle, Dolphin Square, and lots of famous people's houses. Without further ado, I'll hand you over to Derek, who'll present today, and his colleagues from Vent Axia, and we wish them and we thank them for their help and support in today's seminar. Details of further events can be found on our Eventbrite page and or our website at cibse.org. And I thank you for joining us and look forward to sharing with you today's event. Thank you.
Okay, welcome. We're here today to present to you a webinar on domestic legislation for ventilation. This is not a CPD, but we can arrange one for one of our team to deliver this to your organisation if you wish. Please feel free to get in touch with us at cpd@vent-axia.com.
During this presentation, we'll be covering a short background of Vent Axia, the history of Parts F and L and how it is currently, various ventilation systems within Part F, any design considerations, and then any questions you may have. Please feel free to send your questions in as we go through the presentation via the chat.
So Vent Axia, we were founded in 1936 by a marine engineer called Joe Acaster. Joe Acaster was the owner of Axia fans, who manufactured DC fans that were used in ships and tankers. He saw a market for domestic and commercial fans and invented the world's first electrically operated extraction fan, produced in Bakelite. This slide shows a picture of the Silent 6, which was manufactured at the factory in Putney, West London. And today, now called Vent Axia, we continue to improve the indoor environment for our customers.
Vent Axia is a proud UK manufacturer, producing products across 3 UK sites for the UK and export markets, with our goal of improving the indoor air quality for our customers. Our manufacturing facilities across the UK are located in Crawley, Dudley and Reading.
Historically, building regulations across the United Kingdom were combined, but this has now changed to having each constituent country having their own versions of the building regulations. England were the first to publish their latest building regulations. We expect the other countries to follow shortly, with each now having finished their consultation periods, and we look to publish their documents within the next year. Once these are published, we will look to update this presentation to include them.
Moving on to the building regulations, specifically Part F for ventilation and Part L for conservation of fuel and power, we'll be looking at Volume 1, which applies to dwellings, such as residential. There is also a Volume 2, which applies to buildings other than dwellings, such as commercial. This will be covered in a future webinar.
New 2021 edition of Part F, L and O take effect on the 15th of June 2022 in England. This means any new applications following this date will need to meet the 2021 edition. Any applications made prior to this date will be applicable for a 12-month grace period, which ends June 2023. Following this, each individual plot must follow these regulations in order to comply. Historically, building regulations applied to each site, multiple houses, and this is now changed to being specifically applicable to each plot, i.e. individual houses. This means that if a site designed to previous regulations hasn't started every plot by the 2023, any remaining plots would need to be redesigned to meet the 2021 edition.
The history of Part F. Part F of the building regulations were introduced in 1992, with a revision made in 1995, which added utility rooms. It stated that new dwellings must have mechanical ventilation installed within wet rooms, which are defined as kitchens, bathrooms, and toilets. Ventilation of choice back then were intermittent extract fans, which allowed the moist and stale air to be extracted, with air being replaced by infiltration and background ventilators. This not only applied to new build developments, but refurbishment projects also followed this document as good practice if building control was involved. Minimum extract rates meant that generally, to suit application, 100mm diameter fans were used in bathrooms and toilets, and 150mm fans were used in utility rooms and kitchens.
In 2006, Part F introduced continuous whole house ventilation systems and became more focused around performance. There were 4 different types of systems that would meet this compliance: intermittent fans and background ventilators, known as System 1, passive stack, known as System 2, mechanical extract ventilation, known as System 3, and finally, mechanical ventilation with heat recovery, known as System 4. Part L, conservation of fuel and power, was also introduced. This gave rise to fan systems having minimum specific fan power requirements, starting to drive energy efficiency into the systems. Part L was split into L1A for new builds and L2A for refurbishments.
In 2010, Part F was updated to include reference to the Domestic Ventilation Compliance Code, which introduced a requirement for commissioning of systems and compliance documentation, creating a more stringent process for ventilation. Part L, heat recovery efficiencies were increased, minimum SFP targets were lowered, pushing for further energy efficient systems. Alongside this, there were also industry guides and good practice guides to ensure compliance and best practice was followed for installations.
With the introduction of the 2021 edition, the main focus is health and energy efficiency, which we see as a positive move following the COVID-19 pandemic. The regulations look at minimising entry of external pollutants, ensuring humidity and pollutants are extracted effectively and efficiently, and setting minimum levels of fresh air to ensure good occupant health. The approved document references a number of industry guides and codes of practice and standards published by organisations such as CIBSE and BRE.
Approved document F interacts with other approved documents. Part B is all about fire safety. This applies to ducting and penetrations through walls and fire structures. Part B also gives guidance on escape windows and openings. These may well be larger than those required for ventilation in Part F and should take precedence. If in doubt, always consult the fire officer.
Interaction with Part J, which is the combustion appliances and fuel storage systems. Part F cannot supersede Part J when permanently open air vents are required for combustion, as ventilation fans may cause combustion gases to spill from open fluid appliances.
Interaction with Part K and M, which covers protection from falling, access to and use of buildings, which states that controls should be within reasonable reach of occupants.
And finally, Part O, which covers overheating. This is a new approved document introduced in December 2021. This can impact the purge ventilation rates, which may exceed those found in Part F to manage the rapid dilution of pollutants. The higher of the two standards should be followed. There is also a manual to the building regulations, which provides further history and guidance on the various interactions across all the improved documents.
We now move on to the details of approved document F, volume 1.
The various ventilation systems within Part F are no longer classified between the systems 1 to 4. On the left, we have a natural ventilation, previously known as System 1, which is background ventilators and intermittent extract fans. In the middle, we have continuous mechanical extract ventilation, previously known as System 3, continuous mechanical extract ventilation, MEV. And finally, on the right, we have mechanical ventilation with heat recovery, previously known as System 4, which is continuous mechanical ventilation and extract with heat recovery, MVHR. So there now are 3 types of prescribed ventilation systems with passive stack now removed. Other systems, such as positive input ventilation, also known as PIV, may be used to comply, but expert advice should be sought.
In the drive to reduce the energy consumption of buildings, focus has been around improving the fabric insulation levels, reducing heat loss through ventilation, and increasing the building air tightness. How airtight the building is has an impact on its energy use, and these changes to the guidance introduce the requirement that all buildings must be air tightness tested. Air tightness is important as it helps ensure that the energy that's used within a property is retained. As you can see from the thermal image, which compares a well-insulated and airtight house, the standard house in the background has more heat radiation and leakage than the house in the foreground on the right. As per approved document F, houses are now classified as less airtight or highly airtight, depending on the air permeability, which is measured using meters cubed hour per square meter.
The minimum air tightness of a building is 8 meters cubed per meter squared at 50 pascals, which is reduced from 10 in the previous guidance. If the air tightness is greater than this, the building will not comply. If a dwelling designed with natural ventilation tests as highly airtight, which is an air permeability of 3 or less, expert advice should be sought, or a continuous mechanical extract ventilation should be installed. We recommend that intermittent extract fans to be used between 8 and 5, with decentralized and mechanical extract ventilation systems between 5 and 3, and anything below 3 should be mechanically ventilated with heat recovery. The graphic here shows the value at which the building changes from a less to highly airtight, which varies depending on whether it is as built or as designed air permeability.
The minimum intermittent and high extract rates between the 2013 and 2021 editions remain unchanged and are presented within table 1.1 and 1.3. For intermittent systems, these are 60 or 30 for a kitchen, 30 for a utility, 15 for a bathroom, and 6 for a toilet. For continuous systems, these are 13 for a kitchen, 8 for a utility or bathroom, and 6 for a toilet.
A significant change within Part F is the whole dwelling ventilation rates, which have been increased. When applying the whole dwelling ventilation rates are to be taken from table 1.3 and selected depending on the number of bedrooms within the dwelling. For every additional bedroom, there is a requirement to add 6 litres a second per second. These new figures are based on 2 occupants in the master bedroom and 1 in subsequent bedrooms. In addition to these changes, the minimum ventilation rate should not be less than 0.3 litres per second per metre squared of internal floor area, including every floor. Higher of the 2 values calculated should be used. If the house rate exceeds the high extract rate, there is no specific requirement for boost speeds to be increased above the whole house rate, but dependent on various factors such as lifestyle, you should consider a minimum of 10% boost. Also to note, 1 habitable room, for example, a bedsit or studio would fall under 1 habitable room and would need to meet the minimum ventilation rate of 13 litres a second.
Mechanical ventilation systems in regards to approved document L are largely unchanged, but continue to specify that systems should be designed to minimize electric fan power, which is called specific fan power, SFP, and should not be worse than shown in the table. The only change here is that the heat recovery efficiency, which was originally stated to be a minimum of 70% within the Building Services Compliance Guide, in line with the 2013 edition and has increased to a minimum of 73% as part of the 2021 edition. There continues to be a requirement to have a summer bypass and variable speed control for supply and extract ventilation systems. Within SAP, the notional buildings will use natural ventilation with intermittent extract fans.
Natural ventilation with background ventilators and intermittent extract fans, which is suitable for less airtight dwellings, formerly known as System 1. Intermittent extract fans should be fitted in all wet rooms with correctly sized background ventilators, also known as trickle vents.
Here is an animation of natural ventilation. As you can see per the animation, there are background ventilators which allow air to infiltrate into the building. In this example, they are integrated within the windows. Intermittent extract fans are located within the wet rooms, the bathroom and the kitchen, and are only operated either by manual override or automatic controls, such as an integral humidity sensor. These then allow the moist and stale air to be extracted to the outside.
Extract rates are unchanged, but key points to be aware of. If a wet room has no external wall, the fan should extract at 4 air changes per hour in order to meet the purge ventilation standard. It should be noted that for larger wet rooms, this may exceed the minimum extract rate. For example, an internal bathroom of 15 meters squared would need a minimum intermittent rate of 60 meters cubed an hour or 16.7 liters a second. Any automatic controls, such as humidity control, should have a manual override to allow occupants to turn the extraction ventilation on or off. And if no windows are present, the fan should be provided with controls which continue to operate for at least 15 minutes after the room is vacated.
Background ventilators are now defined by single-story or multi-story. There is a 20% increase in area for habitable rooms and a 60% increase in area for kitchens. Fans and background ventilators should be at least 500 millimeters apart if installed in the same room, and if an external facade faces an area of sustained and loud noise, an attenuating background ventilator is needed.
The key note to be aware of is that background ventilators are not recommended in dwellings with only one exposed facade, or if a dwelling has at least 70% of its openings on the same facade. This will mean that apartments will likely need to move towards mechanical extract ventilation or mechanical ventilation with heat recovery.
If there is a habitable room that does not have any windows, you will need to ventilate through another room. In order to comply with this, there should be a permanent opening between the two rooms of at least 1/20th of the combined floor area of the two rooms. Background ventilator of at least 10,000 millimeters squared equivalent area or purge ventilation should be present. This will also apply to continuous mechanical extract ventilation.
A system for purge ventilation is required in each habitable room to remove high concentrations of pollutants from occasional activities, as example, painting. Purge ventilation should be capable of extracting a minimum of 4 air changes per hour per room directly to outside. Purge ventilation should be delivered through either openings such as windows or doors or a mechanical extract system. Where purge ventilation is delivered through openings such as windows, in a habitable room, the minimum openable areas which are specified in Table 1.3 should be achieved. There are minor changes when compared to the 2010 editions, where previously it distinguished between doors and windows. These have now merged into the table we now know as 1.4. Purge ventilation applies to all ventilation system types within a part approved document F.
All internal doors should allow air to flow through the dwelling. The requirement is that there needs to be a free area equivalent to a 10 millimeter undercut to a 760 millimeter wide door, which means either a 10 millimeter undercut above a finished floor or 20 millimeter undercut above an unfinished floor. Although often overlooked on site, this requirement is just a minor rephrasing of the requirements compared to the previous regulation. Door undercuts applies to all ventilation types within approved document F.
We move on to the next type of ventilation system, which is continuous mechanical extract ventilation, which can be achieved through two different types of system or a combination of such. Decentralized mechanical extract ventilation, DMEV, which is a standalone continuously running extract fan that is installed within the wet rooms, or continuous mechanical extract ventilation, MEV, which is a remote fan installed in a loft or cupboard which continuously extracts air from the wet rooms via ductwork. There is no opportunity for heat recovery with either decentralized MEV or centralized MEV.
Here is an animation of decentralized mechanical extract ventilation. Similar to the intermittent extract fans, there are background ventilators which allow air to infiltrate into the building. Please note that these are only installed within habitable rooms and not the wet rooms. With the constant running fans located in the wet rooms, these fans operate constantly at a lower speed to ensure consistent removal of moist and stale air.
Here is an animation of a centralized mechanical extract ventilation system. Again, we have background ventilators which allow air to infiltrate the building. Valves and ductwork are located within the wet rooms, which allow the MEV to draw the moist and stale air through the ductwork and then to outside. For MEV and DMEV systems, we have to look at a high boost rate and also a continuous rate. The minimum high extract rate is defined in litres a second for each of the wet rooms. For kitchens, it's 13 litres a second. Utility and bathrooms are 8 litres a second, and in sanitary accommodation, 6 litres a second.
The continuous extract rate has to be calculated in two ways, and the larger of the two volumes will be used. Step 1 is to obtain the rate from the number of bedrooms. Step 2 is to multiply the total floor area of the property by 0.3 litres per second. Should the continuous rate be higher than the minimum high rate, then the continuous rate should be used for the boost as well. There is no need to increase the speed to give any additional boost. However, dependent on various factors, such as lifestyle, you should consider a minimum of plus 10% boost.
Background ventilators should be installed in the habitable rooms, but should not be installed in the wet rooms. When installed in each habitable room, they should have a minimum size of 4,000 millimetres squared. It should be noted that there needs to be a minimum number of ventilators in the property, which equals the number of bedrooms plus 2.
A point to consider is prevailing winds and exposed facades. This can be combated with any of these points. The best solution is to use constant volume fan units in scenarios where ducting to an alternate facade is not practical.
We move on to the final ventilation type within approved document F, which is mechanical ventilation with heat recovery, MVHR. MVHR is a whole dwelling ventilation system that supplies and extracts air continuously at a low rate, with the option to increase airflow rates for boost as and when required. The unit is typically installed in a loft space or a cupboard and is connected onto rigid ducting, which supplies fresh filtered air to the habitable rooms and extracts stale polluted air from the wet rooms. The unit incorporates a polymer heat exchanger that recovers energy from the stale moist air and tempers the incoming air before it is delivered into the habitable rooms.
Unlike intermittent extract and continuous mechanical extract, background ventilators are not required. Stale and moist air is removed from the wet rooms via the ductwork, which is then extracted to the outside. Simultaneously, fresh air is drawn in from the outside, passes through the heat exchanger where it recovers energy and is then supplied to the habitable rooms. We recommend that the ductwork that is from the unit to atmosphere or installed within an unheated space is insulated to prevent condensation forming.
For an MVHR system, we have to look again at the high boost rate and also a continuous rate, just as we did for the MEV and DMEV systems. The minimum high extract rate is again defined in litres a second for each wet room. Kitchen, 13 litres a second, utility and bathroom, 8 litres a second, and the sanitary accommodation again, 6 litres a second.
Here we repeat the slide from mechanical extract ventilation, where the continuous supply and extract has to be calculated in two ways, and the larger of the two volumes will be used.
The total supply airflow rate should be equal to the total extracted airflow rates. This will allow the system to be balanced, meaning the amount of stale air extracted from the wet rooms is replaced with the fresh tempered air into habitable rooms. This applies to both the continuous rate and the boost high rate. This needs to be achieved by proportionally distributing the airflow rate into each habitable room. Please note that background ventilation should not be installed in mechanical ventilation with heat recovery, as they can provide unwanted additional ventilation and reduce the system efficiency. MVHR should be designed to avoid the moist air from wet rooms recirculating into the habitable rooms.
Within Part F, it states that it shows examples of ventilation systems that comply. Alternative ventilation systems, such as positive input ventilation, also known as PIV, may be used provided it can be shown to have an equal level of performance. This may be demonstrated through expert guidance, which could include use of VBA certification or following BSI PAS 2035, which consider it to be an adequate means of demonstrating compliance.
We now move on to design considerations.
Noise is an important consideration that needs to be addressed, as noise pollution can be a concern within dwellings. Within Part F, it states certain noise levels that should not be exceeded under normal operating conditions, not boost rates. Noise should not exceed 30 decibels within bedrooms and living spaces, and cannot exceed 45 decibels within kitchens and bathrooms.
Counter noise from units, there are various ancillaries that can be installed, such as attenuators, which can be utilised to reduce in-duct noise in certain rooms or the entire system. We have acoustic enclosures, which can reduce the breakout noise experienced from the casing of the unit, and acoustic top boxes, which can be utilised to reduce the overall in-duct noise from the MVHR units. They also provide a neat ducting enclosure at the point of installation. Usually, a combination of these will be utilised to maximise any sound reduction.
As with sound, the location of the property can also affect the level of pollutants that may be drawn into the building, either through trickle vents or through supply ventilation. Section 2 of approved document F states that ventilation systems should be designed to minimize the intake of external air pollutants. In an area of high pollutants, it is likely that this will only be achieved by use of MVHR systems with high-grade filtration. Further information can be found via CIBSE's TM64 and TM40. Further expert advice should be sought during periods of high pollution concentration.
NOx filtration may need to be considered on city centre developments or where lower level dwellings are next to busy carriageways. Again, only applicable to systems that provide supply air rather than background ventilation. It should be noted that adding such filters will add to the pressure in the system, and that these filters will need access for routine maintenance.
Within approved document F, there are requirements to meet for installation and commissioning.
Mechanical ventilation systems must be commissioned by a competent person and notice given to the building control body. There is also a SAP benefit when the ventilation system has been installed by a competent person.
To become a competent person, you can attend a training course, for example, a NIC EIC domestic ventilation course, which is delivered by various training suppliers and Vent Axia in our dedicated training facility in Crawley.
An installation comprises of many components, many of which are specified within Part F. Part F states that the system must be accessible to maintain the equipment and ensure that there are no obvious defects and all packaging has been removed. To the right is an example of a good installation where the unit is accessible compared to a poor installation where the unit is not.
Rigid ductwork should be used wherever possible. The system should be designed to minimize the pressure losses, ensuring efficiency, and sealed to prevent any leakage. Duct connections should be both mechanically fixed and sealed. Examples of a good installation with each connection sealed properly compared to a poor installation where the flexible duct has been taped together with parcel tape.
Flexible ductwork should be kept to a minimum and kept taut and not sagging, or have any tight bends to ensure system efficiency is improved. As you can see from the images, ductwork should be straight and have long sweeping bends where possible, not tangled with multiple bends as per the image.
Airflow rates of all installation systems should be tested and recorded within the commissioning checklist. Correct equipment should be used to measure the airflow rates, which is an airflow device that has been calibrated within the last 12 months at a calibration centre accredited by UGAS.
In some scenarios, the configurations may prevent airflow from being measured. In these scenarios, we will need to determine the airflow rates as per the manufacturer's guidance.
As per Part F, there is a compliance checklist that needs to be completed, which was previously part of the Domestic Ventilation and Commissioning Guide. This can be found within Appendix C, and Part 1 is shown on the slide. Part 1 contains the particulars of the system, address and installer's details. Part 2A is an installation checklist. Part 2B is a visual inspection or pre-commissioning checklist. And Part 3 is for recording airflow measurements from fans. All sections will need to be completed in order to demonstrate compliance.
ADF and L now require a user guide to be provided to the homeowner in the handover pack. It needs to be a non-technical overview for occupiers and should include some basic details on the operation and maintenance of the system. Vent Axia offer a full suite of homeowner guides which can be used to fulfil this requirement.
Excellent. Well, thank you very much for that really useful insight into building regulations approved documents Part F and L. And I hope you'll join me in thanking Dave Sherratt and the whole team from Vent Axia for sharing the information they have with us today. Contact details for David can be found in the description and event bio. We at CIBSE West Midlands region look forward to the next event, details of which can be found on our website, cibse.org or cibsewm.org. And if you go to cibse.org, you need to navigate to the West Midlands region section within the Get Involved and Regions section, or the details of future events can be found on our Eventbrite page. Thank you for joining us today, and I look forward to the next event.